Now it's time to construct the DNF of function x1 implication x2. Again, we construct the truth table of the given function. We mentioned in our previous video that if the truth value of x1 is 1, truth value of x2 is 0, our result will be 0. All the remaining ordered pairs will be 1. In order to construct DNF of the function, we need to choose which ordered pair's truth value is equal to 1. As you can see easily from this example that 0, 0 is equal to 1, 0, 1 is equal to 1, and 1, 1 is equal to 1. From the definition of DNF, you know that DNF is ORing together ends. So all we need is just writing x1 implication x2 is equal to x1, the truth value is 0, and x2, the truth value is again 0, or again x1 is 0, x2 is 1, and ORing together it with x1 is equal to 1, x2 is equal to 1. In DNF, we write the truth value, the truth value of which variable is equal to 1. We write it as itself. We don't change it. But which variable is equal to 0, we will replace this variable by its negation. For example, x1, 0, we will replace it by x1 negation because the truth value of x1 is equal to 0. And x2, 0, again, we will replace it, x2 negation. Or x1, 0 will be replaced by x1 negation, and x2 is 1, so we don't change it. It will remain the same. And finally, x1, 1 will be the same. x2, 1 again will be the same. We don't write here 1. Okay, oh, awful. So our result is just this. Next question, find the DNF of function. Let me show you this like that. Okay, find the DNF of function f(x1), x2, x3 is equal to x1. This is exclusive or just XOR x2 and conjunction x3. This is the opposite of biconditional. Let's construct the truth table of this given function. Okay, I have already constructed it. So, the opposite of biconditional is if the truth values of all the variables are the same, our result will be the same. Okay, here also the truth values of all two variables are same. Again, the result is 0. So, x1, x2 is 0. Again, 0. The 0 is because the truth values are the same. Here is the result also 0 because the truth values are the same. This is the opposite of biconditional. So, This is the truth table. The final result is this. In order to construct the DNF, all we need is to choose the answers, the results of 1. Which result is 1? This and this one. So let's choose the ordered triples. This one, ordered triple, and this final one. Okay, it's time to write all these triples. If x1, x2, x3 is equal to the result is 1, this ordered triple is x1 0, x2 0, x3 1, x1 0, x2 0, x3 1. DNF is ORing together ends, so between them there are conjunctions, disjunctions, and among the braces there is conjunction. Next one, x1 0, x2 1, x3 0, x1 0 and x2 1 and x3 0. Or next, x1 0, x2 1 and x3 1. Or let's continue, x1 1, x2 0 and x3 0. Let's continue, x1 1 and x2 0 and x3 1. And the final triple is x1 1, x2 1 and x3 1. Now all we need to do is just replacing the zeros by the negation of this variable, and but the truth values of which variable is equal to 1, they will remain the same. Okay, x1 0 will be changed to x1 negation, x2 0 again x2 negation, but the truth value of x3 is equal to 1, therefore it will be the same. Again, x1 0 will be x1 negation, x2 1 will be the same, x3 0 will become x3 negation. Or x1 0, again we will change it by x1 negation, x2 1 will remain, x3 1 also will remain the same. Here x1 is 1, it will remain the same, x2 is 0, we will change it, we will replace it by x2 negation, and also we will replace x3 negation because its truth value is equal to 0. And x1 1 will be the same, x2 negation because it's 0, and x3 will be the same, and finally x1, x2 and x3 will be the same because the truth values all these three variables is equal to 0. So this is the DNF of given function. And the final example, construct the DNF of given function fx1, x2 is equal to 0, 1, 0, 1. Again, we should construct the truth table of this function. This is any function. We don't know which function is it. It's just example. If you are given such type of example, you should construct the truth table. Okay, and if we want to find the DNF, all we need to choose the ordered pairs which is equal to 1. Okay, and let's construct f x1 x2 is equal to x1 0 x2 1, x1 0 and x2 1, or x1 1 and x2 1. So again we replace the zeros by negation, x1 negation, and we will remain the same which truth value of the variable is equal to 1. x2 will be the same because its truth value is equal to 1, or x1 and x2 will be the same, will remain the same because its truth values are equal to 1. So this is all. If you have any question, please let me know by asking, writing the comments below, and I will explain it. Thank you.